right, once again, today is Monday, February the 8th, 2021, 8G6. Somebody read that to us.
I can prove the Pythagorean Theorem with 60% mastery.
Good job. It is known as the Pythagorean Theorem. It is something that you will hear quite often again when you get to Algebra 1. All right, a few vocabulary. Somebody tell us what a theorem is.
Statement of a mathematical idea that someone has proven to be true.
Good job. So something is only a theorem after someone has proven it to be true. That's the only time it's considered a theorem. You will learn a lot about theorems, as I stated, when you get to algebra as well as geometry. All right, somebody tell us about a right triangle.
Triangle with one right angle.
It's something you started learning possibly in 3rd grade. A right triangle at least has one right angle. The other two angles are acute. All right, somebody tell us about legs.
Two sides adjacent to the right angle touching shorter sides.
All right, last week we learned adjacent mean what? We forgot adjacent mean beside. So we're talking about the legs on that right angle. We're talking about those two legs that's right there beside that right angle. Here, take to the picture there, show you the two legs. All right, somebody tell us what that third side is. Hypotenuse.
Side opposite right angle alongside.
Good job. It's known as a hypotenuse. That is the longest side on a right angle, right triangle. It's the longest side, and it's opposite that right angle. We know it because it represents that slant. All right, the Pythagorean theorem. Someone tell us what it states.
That the square of a hypotenuse of a right triangle has an area equal to the combined areas of the squares on the other two sides.
All right, so the Pythagorean theorem pretty much tells us the sum of the squares of the legs is equal to the hypotenuse. One form to remember, a squared plus b squared equals 2c squared. That is the Pythagorean theorem. If you learn nothing else, you learn that a squared plus b squared equals 2c squared. C is always the hypotenuse, which is your longest side. If that formula works for different numbers, that means it is a right triangle. If it doesn't work, that means it's not a right triangle. All right, somebody read that to us.
You can prove if a triangle is a right triangle by knowing if it satisfies the equation a squared plus b squared equals c squared.
All right, so if you ain't got nothing else on your paper right now, go ahead and put that formula. A squared plus b squared equals c squared. We will be using it. Anytime we mention Pythagorean theorem, that's what to think of. All right, your practice is found in the usual place. Most of us pull it up and have it waiting for us. Yes, ma'am, I will. Let me know when you got it, Lakeland. All right. All right, they gave you a few minutes to find your practice in Schoology. You should also have paper and pencil. I'm dealing with a formula, so that definitely means I need something to look at. All right, once you get there, somebody read number 1 to us.
The side length of 4 triangles are listed below. Determine whether each triangle is a right triangle.
Good job, thank you. All right. Now remember we said if it makes a right triangle, it has to satisfy the formula a squared plus b squared equals c squared. C is always your longest side, or whatever your longest number is. So for each of these answer choices, we're gonna have to substitute them into that equation and see if they'll work. For instance, 8. The longest side is 6. So that means I would have 4 squared plus 5 squared, and I would try to prove if it's equal to 6 squared. What's 4 squared, somebody?
16.
5 squared.
25.
Squared.
36.
36.
16 plus 25.
41.
41 the same as 36?
No.
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 So will that be a right triangle?
No.
No. Only if it works. All right, let's try B. For B, which would be C? Which is the longest?
13.
13 would be our C. So we're going to substitute it into the equation again. So that means we'll have 5 squared plus 12 squared, trying to prove it's 13 squared. What's 5 squared?
25.
12
5.
squared.
144.
13 squared.
169.
All right, add 25 and 144.
169.
169 is equal to 169, so that means B would make a right triangle. Looking at C, which would be our hypotenuse?
17.
Good job. So that means we will have a squared plus 15 squared, trying to prove if it equals to 17 squared. What's 8 squared?
64.
64.
All right, 15 squared.
225.
All right, 17 squared.
289.
4 and 229. I mean 225.
289.
Two of you talking at once. What you got?
289.
All right, that was the same value we started with, so that would make a right triangle as well. Looking at D, which would be C?
20.
Great job. So that means we would have 10 squared plus 15 squared, trying to prove if it equals to 20 squared. What's 10 squared?
100.
All right, 15 squared.
225.
All right, 20 squared.
400.
100 and 225 would be 325, which definitely is not equal to 400. So that means that would not make a right triangle as well. Any questions about it?
No, ma'am.
Anyone still need anything?
Yes.
All right, let me know when you finish, Angelo. It is a text box, so common sense will tell you I need more than no, yes, yes, and no.
Got it.
All right, somebody read question 2 to us.
Explain how the following diagram demonstrates the Pythagorean theorem.
Now, what do we state about that Pythagorean theorem? What does it tell us?
That the square on the hypothesis of a right triangle has an area equal to combine of the squares on the other two sides.
Alright, so the Pythagorean theorem tells us the sum of the legs is equal to the sum of the hypotenuse. Does this diagram show us this? What do you notice in the diagram? What are our side lengths? What would that mean? Square. All right, let's look at the legs on this right angle. If this is the right angle, what are our legs?
4 and 3.
Okay. So if we're following that formula, that means that'll be 4 squared plus 3 squared. Look at the hypotenuse. How long did they say the hypotenuse is?
5.
What is 4 squared? What is 3 squared? What is 5 squared?
4 squared is 16, 3 squared is 9, and 5 squared is 25. 16 plus 9 is 25.
All right, so explain how this diagram is showing the Pythagorean theorem. What did it show us? So we're waiting on me to say what it showed us. All right, Alyssa says that it's a right angle and it matches the equation. So yeah, that's pretty much what I can note. This diagram is showing that side lengths of 3 and 4 can have a hypotenuse of 5 and be a right angle. Good job, Alyssa. Number 3, somebody read it to us.
Paul sketches a right triangle with legs of lengths A and B and a hypotenuse of length H. He writes an equation that relates A, B, and H, and then he writes an expression for the length of the hypotenuse. Which expression does he write?
Before I can even pick out an expression, they told us that Paul did something that I may need to do. What did they tell us Paul did?
He sketched a right triangle with legs of lengths A and B and a hypotenuse of length H.
I'm gonna do the same thing Paul did. I'm gonna draw this triangle so I can see what they're talking about. They said it got legs of A and B and a hypotenuse of H. And they said write an equation that would represent the hypotenuse. Before we can even get to the hypotenuse, what equation will we have for the Pythagorean theorem with the variables that they gave us? Looking at that model, how can we write that Pythagorean theorem?
A squared plus B squared equals H squared.
All right, and they told us we're trying to get H by itself. Right now, H is being squared. So how can I get rid of a square to get H by itself? Who remembers what get rid of a square? How do I undo a square? Take a what?
Square root it?
Good job, Lakeland. That is correct. So that means that's something I did not know. That's definitely something I need to get down. Square and the square root undo each other. So that means if I have a square and I'm trying to get it by itself, I need to take the square root. Of both sides. That's going to eliminate on that side, leaving us with H is equal to the square root of A squared plus B squared. What's our answer?
A.
Good job.
What was the answer?
Steven, what did you say it was?
D.
All right, somebody read it to us.
Consider the diagram of a square within a square shown below. Write an expression using the links from the diagram for each of the following.
All right, the first one says the area of the large square in terms of A and B. How do we find the area of that large square? How do you find the area of a square?
Multiply the length by the width.
Or in other words, side by side, since it's a square. So that'll be side times side. So in other words, side squared. So what is one side length of the larger square?
A plus B.
Good job, Lakeland. That is correct. A plus B. So if I'm finding the area of it, that'll be A plus B squared. Great job. How would I find the area of that small square?
Interior C would be the same thing as if it was on the outside, so you can basically just consider.
So you're going with C? And what you doing with C?
Wouldn't it be c squared?
All right, so now they say the total area of the four triangles. So now ignore the squares and just look at the triangle. How will we find the area of one of those triangles? How do you find the area of a triangle?
Ain't it 1/2 BH?
Good job. So what's the base and the height of one of those rectangles, triangles?
A and B.
So that'll be 4 times 1/2 times A and B, or AB. What's a half times 4?
2.
Good job. So that'll be 2AB. All right, part B asks, explain how to use your results from part A to prove the Pythagorean theorem. What can we use from A to prove the Pythagorean theorem? So then that's where I ask myself, what is the Pythagorean theorem and what parts represent the Pythagorean theorem in this problem? All right, somebody read number 5 to us.
If two legs of a right triangle are 2 inches and 3 inches, can be, what's that word?
Hypotenuse.
Hypotenuse be 4 inches. Just by your answer.
How can we prove this to be true or not true?
First, we need to work the equation.
All right, what's the equation?
Two squared plus 3 squared equals 4 squared, I think.
How you know 4 is your c squared?
Because it's the hypotenuse.
Good job. It's the hypotenuse, and the hypotenuse is always the longest side. All right, so satisfied or solid?
Nine. 16. 13.
13.
So what can we say?
No, it cannot, because it does not support the Pythagorean theorem.
We're gonna say satisfied, Lakeland. And as you move through algebra and geometry, you will understand why I use the term satisfied. But great explanation. No, it is not a right triangle because it does not satisfy the Pythagorean theorem And then, of course, you can explain what you got in the Pythagorean theorem. 13 is not equal to 16 after I did 2 squared and 3 squared. Any questions about it? In Schoology this morning, you received some notices, some things I'm still missing from some of you. Mainly being I read it math and star math. 2 weeks. I've been asking you to get your stuff completed. These are the remaining students who need to complete I read it math. India, Jaquan, Edward, Brian, Daniel, Azaria, Peyton, Madison, Yolana, Shatoria, Christopher, Zaya, Kadarian, Courtney, Stevie, Eric, Jayla, Kenneth, Harmony, DeKyla, Octavius. I read it math need to be complete this week. Start math, we got an even longer list. You wondering why your grades are the way they are for math? This is one reason. 2 weeks, I'm begging you to get your stuff done. India, Zaria, Marion, Corey, Darren, Madison, Jayla, Kenneth, Kader, Harmony, Jacoby, Jemiah, Octavius, Zakiria, Cornelius, Daniel, Cameron Hall, James Lockhart, Christopher, Jaquan, Zaya, Javante, Kendrick, London, Eddie, America, Kiana, Yolana, Stevie, LeJerick, Eric, DeKyla, Eric, Shatoria, and Brian. Still need to complete start math. The month to password is admin3. Take care of your business. Progress reports have changed to this Friday. So if you still have work from last week that you still have not completed, business to get it complete before Wednesday. As always, have a great Monday.